Hello and welcome to What's New with Azure Machine Learning. My name is Seth Juarez, Principal Cloud Advocate here at Microsoft, and I thought we'd start with an agenda. First, we're going to talk about what we're building. Second, we're going to see how the IT administrator or infrastructure person feels about it. Third, we're going to see how the data scientists actually do this, and then we'll do a review. Let's start with the delicious problem. I love Mexican food, and I thought I would suggest to our giant corporation that we should start a fleet of taco trucks, especially during this interesting time, safe way to enjoy the food. But they are a results-driven bunch, and they want to know, is this going to actually work? So I thought, well, what if we could build a system whereby we could automatically know how many tacos or burritos we're selling just by the computer looking at it, and number two, figure out how people actually feel about it through their written reviews. Well, that's what we're going to do in this session. Anthony Bartolo, our IT professional, is going to set up the infrastructure. Cassie and I are going to build it, and then you're going to see some amazing features in Azure Machine Learning. So let's start with infrastructure. Anthony, I want to start with you. Is this something we can actually do in our giant enterprise?
Thanks, Seth. I'm so glad you came to us prior to starting this machine learning project. Having IT involved at the beginning ensures that we achieve our organization's goals together without incurring policy or compliance issues down the road. Security and governance features like network isolation, managed identity, RBAC, policy, and other compliance considerations are top of mind here at Tailwind Traders. But creating a machine learning solution in a manner that is secure and meets our enterprise compliance requirements is challenging. Azure Machine Learning now can build and train ML models with managed and secure cloud-hosted workstations or compute instances with security features that include private VNets, role-based access control, managed service identity, and the ability to deploy models on private AKS clusters to complete the ML lifecycle. Thank you for sharing with me ahead of time what the organization is attempting to accomplish. Here are my recommendations on fully securing the environment to train and deploy models securely. All resources are to be offered inside of a virtual network with no public access and would require a VPN to gain access. Managed identity service should also be used to securely communicate between resources. Role-based access control should also be enforced and to ensure that least privilege activity is enabled for the data scientists. When was the last time you carried cash to pay for something? Most transactions these days are paid for by credit card. In capturing these transactions, there's a possibility of capturing pie, which has its own challenges in terms of what information can be accessed, even if the data is being used to simply train a model. The recommendation is to secure all compute resources and data storage via private IPs on separate VNets. In this configuration, data scientists would need a VPN to gain access to the machine learning workspace to be able to run the exercise. The computer instance running this exercise will be granted access to the data storage located on a separate VNet via managed service instance, allowing no other access to the potentially sensitive data. This is a simple example of how a VNet is created, specifically creating a private subnet. In this scenario here, we'll be creating a space under 172.16.0.0. As you can see, the space is being created inside of the Azure portal. This is something that's traditionally for Azure networking that's made available to IT administrators as a tool to create the specific subnets. In using managed service identities, we can allow one Azure resource instance to authenticate against another without access keys or passwords. In our setup, we'll be using a system-assigned managed identity, which will be assigned to a single resource instance and deleted automatically when the resource is deleted. In Azure ML, managed identities can be used for adminless Azure Container Registry for training or scoring Docker images, credentialless storage access for training data, and even preview of datasets using the Studio UI. Last but not least, we want to invoke least privilege access on behalf of Tailwind Traders data scientists to ensure sensitive data is not accessed and that the computes are not modified to ensure our organization's standards are adhered to. Role-based access control provides the ability to assign data scientists roles who are empowered to train models and nothing more. Other roles that can be created include DevOps engineers who can register and deploy models, and data engineers who can register data stores. And don't worry, I have received and have approved your request based on our organization's guidelines for a custom role to be created and assigned to you. I've gone ahead and edited an existing administrator JSON file and disabled the ability to manage anything connected to identity and manage service identity. You'll still have the ability to provision new compute instances on behalf of your data scientists, but I will still require you to submit a request to make any changes from there. There is a GUI interface that this can be completed on, but I prefer to use Azure CLI as it makes it quicker for me to modify RBAC roles and allows me the ability to apply versioning should I need to backtrack on actions that I've enabled in case of an error. And so here's what our finalized Taco Truck machine learning workspace will look like when completed. As mentioned, all resources inside of the virtual network will have no public access and will require VPN to gain access to. Managed service identities has been assigned to the compute instance to ensure secure communication between resources, and role-based access control has been invoked to enforce least privileged access to resources and to ensure our organization stays compliant. Just let me know if anything else is needed or any further changes are required. Back to you, Seth.
Thank you so much, Anthony. That was amazing. And now that we have an IT-blessed Azure Machine Learning workspace, I thought we'd review some of the cool stuff that's coming out. You obviously saw optimized roles with RBAC support for the data science process. And in public preview, we have compute instance setup scripts and something he did not mention, one more thing. Now you can Arc enable some of your remote compute, even on premises, to train your models directly from Azure Machine Learning. It's pretty amazing. Use Synapse. You can also use Spark clusters directly from Azure Machine Learning. Okay, so now that we have our IT infrastructure set up, it's time to start with phase one of what we're building. What would data scientists do? And the first thing we're going to do is we're going to try to recognize dishes as they go over the counter. We're going to have a camera, and if it can take a picture and know exactly what it is, that's what we're going to build. In Azure Machine Learning, there is something called a data labeling feature. We're going to go ahead and see if that will work for our first model. All right, let's get to it. The first thing we got to do is map our blob storage where all of our images are located to the Azure Machine Learning Studio. And to do that, we use the data store. We've already mapped it. We're calling it Taco Pictures, and this points to our blob storage. Done. Now let's go to data labeling, and let's create a new project. We're going to call this one Northwest Food. And I want to show you that there's 4 different kinds of things that you can do in image or data labeling. The first is image classification, multi-class, where you select a taco or a burrito. Image classification multi-label, where there can be multiple things in the picture. This one's cool because you can actually select the bounding box around the taco or burrito. And this one, currently in preview, is instance segmentation, where you can select the actual polygon around the taco and or burrito. For our purposes, we're only going to have to do the image classification multi-class. All right, let's hit next. The next thing we have to do is select a data set. We're going to create a new one from our data store, and we're going to call this Food Pictures, and hit next. We're going to use the Taco Pictures Azure Blob Storage. What the data store does is it's a mapping of a view inside of the storage. You'll see that next. We'll hit select, and then we'll pick the path inside of this storage. Notice that we're using the root path, but you could choose any path from the data store. In this case, we're using the root, and there is all of our pictures. And then we'll hit next. Looks like the data set has been created. We'll use Food Pictures and hit next. Incremental refresh allows a data set to be periodically checked for new pictures. We're going to select that. And then there's 2 labels for us, burrito and tacos. Let's hit next. Finally, some instructions for the people that will be doing the labeling. And we'll bold these. Then hit next. And this is probably the coolest part. We can accelerate our labeling project by turning on ML-assisted labeling, which trains a model to pre-label data for your labelers to review. It's pretty cool. We already have a compute target, so we're going to use our Gandalf machine learning cluster. And now we can hit Create Project. All right, now it's time to actually label the data. Now, this part is pretty boring, so I am just going to speed this up. Now that we're done labeling and you saw some of the intelligent labeling that was happening, notice that we can go into the training itself and we can actually look at the run. This here seems to be a pretty good run. And notice that it actually created a model for us. This model looks like it has 97.05% accuracy, which is amazing. So why not just use this model? We can just deploy it and use it. The coolest part is that the ML-assisted labeling built the model for us. We don't even have to do anything after that. We can literally just click deploy. And since we're in a time crunch and we've worked all weekend to get this to work, thank goodness Cassie in Minnesota is working in parallel with me to build the actual review model. Cassie, how's it going?
Thanks, Seth. Super excited to show you what I've been working on over here in Minnesota. I have been working on our natural language processing model that is going to analyze the sentiment of the reviews given to our tacos and burritos. So here's what the data set looks like. I have text data that is a review, and then I have a rating from 1 to 5, 5 being the highest and 1 being the lowest. So we are going to be using Azure Machine Learning and all of its awesomeness and all of the new features to help build this model. And the first one that I want to point out is the Azure Machine Learning terminal that is built into AML now. So if you are familiar with the Azure CLI, you can do all of your commands right within Azure Machine Learning. You don't have to go outside of it. It's kind of like Cloud Shell if you've ever used that. And it's a quick access terminal that you can use. So let's take a look at how I use this to clone our repo. So I'm going to go into Notebooks, and from there, I'm going to click Terminal. And this is going to open up my terminal experience, again, right within my Azure Machine Learning workspace. We can see here that I'm in my directory, and I'm just going to type git clone, and then I'm going to clone in that repo. So this is the repo that I've been working on for our natural language processing model. It's going to show up right on the left here in our workspace now. So awesome. Now I have the code that I need to start working on our model. So I'm going to go into focus mode so I get some more workspace, and I'm going to use AZML experiment list, and that's going to list out my experiments that I have in AML. And I can also list out my data set. So the taco reviews is our source data set that we're going to be using. If I want to look at some of the data on that, again, that's another command that I could run right in AML. So those are some cool new features that we have within the terminal and the AZML integration. The next thing I want to look at is our new and improved ways of working with data. Obviously, data is the backbone of everything that we do, so we can't do anything with models, we can't create anything without data. And so having really cool tools and versioning and integration with our data sets is an important part to being able to create good machine learning models. So some of the new things I'm going to show you is that we can upload from both Pandas and Spark data frames directly into Azure Machine Learning from our Jupyter notebooks or whatever environment we're using for development. We can now mount compute, and then we can also have input and output data sets for our pipeline. So I can specify my data set. I can have that as an input at a step in my machine learning pipeline that is then an output to the next step, and then eventually registering that as a new data set in Azure Machine Learning. And we're going to see how all of that works. This is great for versioning, lineage, tracking, audit, and also for all the collaboration that Seth and I were doing. It helped us be able to really keep versions of what we were doing all within one place so we could access it and see what was going on. So I'm going to go into the notebooks feature here. I'm going to go to my Azure Machine Learning Jupyter notebook that I have saved that we just got from the GitHub repo. And so you can run notebooks right in AML, and I can run each cell just like I would. I have my imports and setting up my workspace. And at the top, you'll see a lot of your familiar navigations. There's some new ones too, like a table of contents. And then if we go to the hamburger menu, I can actually see a lot of other things that may not look anything new, but there are some new things in here. One is the editors, and two is that I can export. So I can export as a Python file. I can also do HTML or notebook. But the cool thing is if I'm experimenting with my notebook, I can export that to a Python file without having to copy and paste everything over. I can open that in VS Code and I can run the cell right within that Python file and have this integrated environment right within VS Code. So that's a super cool new feature. So let's exit out of this and go over to our hamburger menu and look at some of the other things in here. So the other really neat feature we have is the edit in VS Code. So what that's actually going to do is it's going to connect to my cloud environment with the notebook that I was working on. And if you take a look, you can see that I can run this Jupyter Notebook right in VS Code. And in the left here, I'm actually using my Azure kernel right here. So I am using, it's an SSH into my cloud environment to run my Jupyter Notebook locally in VS Code. I don't have to do any Conda environment setup since that's already done for me. So it's really super quick and easy to start developing on any machine while leveraging the power of the AZML extension in VS Code. So you can see I'm setting up my environment here. And then now that I'm all connected, I want to take a look at registering some Pandas data frames right into the Azure Data Store. So this is a local data frame that I just created, just a little test one with, great tacos and some ratings here. And when I run this, it's going to create that data frame and it's going to register it into my AML workspace right from my notebook. So I'm going to click on datasets. I'm going to go into my Pandas data frame that I just created and I can click explore. And there it is. There is that data frame that I just created ready in Azure Machine Learning. So now I'm going to go back to notebooks. I'm going to click on the editors and I'm just going to edit in Jupyter Notebook. So maybe you prefer to use Jupyter Notebook and you can use that cloud environment right within the IDE that you're comfortable with. So here again, I can shift enter to run through. I have my kind of dependencies in my environments. And now I'm connecting to my data store Taco Reviews, which is my source data set for this. Now, if I run the upload data set again, it's just going to create a new version. It won't overwrite what's there. It will keep all the versions and I can then pull different versions as well, which is really cool. So here I want to create my Taco Review data set and let's take a quick look at what that looks like. So I'm going to go to datasets. I'm going to click on Taco Reviews and I have some sample ways to consume the data, some sample code, and then I also have the ability to explore the data. So we saw that I want to grab the CSV train since that's my training data. I'm going to load that into a Pandas data frame directly from the data store. And here I'm setting up the prep path for my data. If I go into storage, I can go to the prep path that we're setting up. And if I click into that, I can see the output of my prep steps. So my prep steps actually going through and creating those word embeddings, exporting them to a Parquet file, which we'll see. And I'm exporting them directly with the output file data set directly to AML. So that's going to look at my prepare script. And then I also have my step that I'm going to have the run config that I just set up. I'm going to have my output path. And we can take a quick look at what the prepare script looks like. So we can see how we are integrating with these calls that we're making. So here you can see where I'm grabbing the arguments that I'm sending in. We can take a look at get processed data where you can see I'm passing in my input and output path that we are registering in that step in the notebook. I'm loading my data set, I'm creating my vocabulary, and then from there I am parsing out that vocabulary into Parquet files and storing that in Azure Storage, and then registering that as a data set. So if we go look at what the output data set looks like, and I go to Explore, we can see that output data right here. So really, really cool. I can look at it at storage. I can look at it in Azure Machine Learning. I can register it and do all of that right from my notebook. So then for training, I want to do the same thing. I want to output my models to my output file data store. I'm setting up that in path here as well. So if I go back to Taco's review and I click on train and I scroll down to my latest run, I can see my vocab and my model exported into my Azure Machine Learning storage. And that's all done automatically through the pipeline by registering these paths in the config and the script step for when we submit our pipeline. And then now we are ready to actually submit that pipeline. So there we can see the prep step and the train step. We can see that we're creating that experiment. We're submitting that experiment and passing in the pipeline. So that's going to do both of our steps. And if we go take a look at Azure Machine Learning, since that takes a little while to run, let's jump into one that has already run and take a look at what it looks like. So if I go into my prepare step, I have all kinds of goodness that I can look at here. So I can look at the logs, and this is going to, any of your print statements from your run is going to be in here, as well as the Azure Machine Learning outputs. I can look at a snapshot. So if I'm wondering, maybe I made some changes to my script, I can take a quick look and see which one was used in this particular run, or maybe it was ones that Seth was running and I want to see what he did. I can take a look at details that give me different tags and information. So on the train step, I get that same thing. I am also getting metrics here because I'm using MLflow, which integrates into AML and allows me to get all those important metrics that I need to help understand how my model is performing. So you can see here, this one probably wasn't the best run. Hopefully we have some better ones than that. But it's really cool, like right within the pipeline, I can take a look at that. So we can see that the one that I just submitted is running, and that's going to take a little while. And if you click into it, you can get the status of what's going on. I can see that it's running, and I can look at the logs and all that good stuff. So the other thing is, because we have the prepared data stored as its own data set, we also have this train-only notebook. And in the train-only notebook, I can run that same model, but I can grab my prepared data set from Azure Machine Learning, so that tacos, reviews, prep, and just run the training as an experiment. And so that saves me a lot of time because I don't have to do that word embedding every time I want to try some new epochs and layers and learning rates and all those hyperparameters. So that's really cool. It's going to save me a lot of time. And then also Seth could go in and grab the prepared data from maybe one of my runs and then put it into a training step. So once we have the data in there, we get some cool features, right? Like I can put different tags on it. I can change my view for this experiment to see better what's going on and which run I like. I can select individual ones, and that brings those metrics that I'm logging right up to the top, or I can select multiple here. So if we take a look, I can select all the runs based on the filters or whatever I have set up in this custom view. And for here, I can hover over and I can see the metrics. I can make that bigger so I can get a better view. I can remove different ones, like maybe I want to get a more detailed view. I can click and drag to zoom in and double click to get back out. So lots of cool features. This dashboard was actually created by Seth. He sent it to me because we can share it directly. You can copy that URL, send it to anyone that has access to the workspace, and they can also come in here and take a look. I could add new charts. Maybe there's some things that I want to add, but I think Seth did a pretty good job on this one. I'm happy with the way it looks. So really cool custom views that I can do. The next thing that I can do with the custom views now is I can go to all runs. Here I can look at runs across multiple experiments. So I can search by NLP sentiment, and I have a couple different ones here, right? And maybe I want to take a look at multiple experiments and runs all on the same dashboard. So I can now do that as well. So let's go back to all experiments. Let's take a look at which one we think is going to be performing well. I'm thinking it's looking like run 61 looked pretty good. So let's click into that one. And down here, we can actually see the registered model that was created. And we can go ahead and deploy that to an endpoint so we can automate checking on the reviews that are getting submitted. And we can get those ratings. So I want to get my score.py file. And then I want to grab my conda dependencies YAML file as well, so I can have my container set up with the right dependencies, and then I can click deploy. So this is going to deploy my model for me. We can go to endpoints. We can see the different ones that have already been deployed. I can click into this one and I can see that it's still setting up, and then what the endpoint will be when it's ready. Now that it is deployed, I can grab the endpoint and we can take a look at how this model is working. Let's see how accurate our taco reviews endpoint is. So I'm just going to do text equals in the query string at the top and just say, I love tacos. And that's a rating 5. That's the highest rating. That's awesome. Looks like it's working. Okay, let's try meh. It's a 2. Yeah, I'd say 2 or 3 is probably right for meh. Let's see what else. The tacos were bad. And so was the service. Okay, that got a 1. That's probably right. I mean, that's not a positive review, so 1 seems right. So it looks like we have a pretty accurate model going here, which is pretty cool. Yuck is a 1. Yeah, awesome. So we went over a lot of really cool features that we have in AML. We have now a working machine learning vision model and a natural language processing model to see how people are liking our food at our food truck. And we were able to work together virtually. Like I said, I'm in Minnesota, Seth is in Seattle. Azure Machine Learning made us be able to work together really well, even though we're in this virtual world right now, right? We had centralized trainings, we had shared notebooks, shared datasets, versioning, tracking, the custom views. So if we wanted someone to take a look at something, we could send that over by setting up a dashboard, saving it, and sending it. The cross-experiment run comparison. And then we also have the added security features that make sure that we're only getting access to what we should be getting access to. So thanks so much. I'm going to pass it back to Seth, and I think he has some more cool things to show you.
It's true. Cassie and I actually really love tacos, and I'm so glad we could literally work on this together in the same IT-blessed workspace with the same data, with literally the same code. But wait, there's more. What if management wants us to build models for each location? We have something called the Many Model Solution Accelerator that empowers developers and data scientists to build models, millions of models, for every single location using features like parallel run step as well as data partitioning. But let's talk about model explainability and fairness. And the reason why we need to is because we need to understand if we're using machine learning responsibly. Inside of Azure Machine Learning, we have 2 dashboards to help you with that. Okay, let's take a look at explanations and fairness. Now, we don't have a model for our taco trucks that causes the harms that we've talked about. So we're going to look at a responsible AI loan decision model just so that we can answer any questions that may come up. The first thing that's cool is you can take a look at the entire data set to see the probability of someone being rejected. We can also add new cohorts, such as age less than or equal to 30 or age greater than 30, and you can see how the model performs across those axes. You can also look at the data itself. You can change how you view the data by the feature as well as the cohort that you'd like to take a look at. You can also take a look at the aggregated feature importance. In other words, the features that are most important for making predictions, and you can learn more about those across cohorts. Finally, you can look at individual feature importance across cohorts and across features. And if you click on one of them, you can also take a look at the features that cause the model to predict how it did. And you can even take a look at the actual features. Now let's move over to fairness. With our fairness toolkit, we can evaluate our model against sensitive features that we've selected, and you have the option to do that. In this case, we're going to choose gender and hit next. And we're going to index on accuracy. Finally, we're going to look at the demographic parity difference and hit next. Now, as you're looking at this, these are a bunch of models that were created to mitigate fairness. Notice that this represents the disparity and this represents the accuracy. Notice that we want to have good accuracy, but we want to have low disparity. Let me show you what that looks like for something in the middle, for example. Notice that the disparity between loan decisions is 74%, and we don't want that. And you can see the selection rate for males is much higher than it is for females, and you can see that the false positive and false negative rates are clearly unbalanced. If we go back to a model that's a little bit more balanced, you can see that the disparity is much lower and that the negative and positive rates, again, there is a little bit of an imbalance, but it's actually more fair. These two features combined empower people that build machine learning models to be able to explain and mitigate any unfairness that happens in machine learning models, allowing us to, as an organization, have responsible AI inside of our applications. It's really cool that Azure Machine Learning has thought of everything from building things together to being responsible. Now generally available, you have the custom views, the cross-experiment views and comparisons of runs. You have the native terminal and the output data sets. And in public preview, the labeling for image segmentation that we showed earlier, the many model solution accelerator, and the interpretability and fairness dashboards. A lot of cool stuff. All right, so what did we just see? We had a really good idea about taco trucks. We had to pitch it to our corporation. So we decided to talk to our IT pro. We saw how the data scientists would work the problem. And then we had an amazing solution. Here's some links to find out more. Hopefully this taco truck idea takes off. Thanks for watching. We'll see you next time.